Okay, so some people eventually ask, where do these kinematic equations come from? The three equations being, x is x naught plus v naught t plus 1/2 at squared. The velocity equation, v naught plus at. And then our equation that doesn't have time, so vf squared is v naught squared plus 2a times delta x, or xf minus x naught. So these are our three kinematic equations, and what I'm going to do is I'm going to derive each of these starting from definitions. And so let me just separate these. So we'll just be using these, and we'll get to these three equations. The little bar, what that means is average. So what this is the average velocity. So the average velocity is the displacement over time. The average velocity is also, if we just add the initial and final and then divide by 2, that will tell me the average velocity. That's just a arithmetic average. And then acceleration is the change in velocity over time. So these are just definitions that we have. And so I can begin with this one, the average velocity. So average velocity is going to be displacement over time. And then if I multiply that across, I get the change in position is equal to the average velocity times time. I flipped it around because I like my deltas. So I multiply that across, times t, like that. And then I reversed it. So we have this equation, but that's not very useful. That just tells me how far. You might recognize this one. They teach it in middle school. The distance is equal to the rate times time. So if I know how fast the average velocity I'm going and how much time, I can tell you how far I went. And that's only for constant velocity. But we don't want that. We need to take into account acceleration. And so what I'm going to do is I'm going to pull this other definition down. So v naught is the average velocity is, or actually, you know what? Let's just go straight in. So I think we can let's just substitute that in. So we're just going to, let's do this. Instead, what we're going to do is we're going to substitute this part. So this is going to go in there for the average velocity, because I want to know on real velocities. I don't want to take the average. So I'll just substitute. So that's v naught plus vf divided by 2 times t. And then if I take the acceleration, delta v over t, and I multiply that across, I get a times t equals delta v. And to calculate the change in velocity, so that would be, I'm gonna flip these around. That would be final velocity minus initial velocity is equal to acceleration times time. That's the delta is this part. And then I just move that over. I get final velocity is equal to the initial velocity plus the acceleration times time. And that's this equation right here. This is number 2. So we've already done number 2. But now what I can do is I can take this and I can substitute it. We're going to put it in there, into this equation. So I'm going to pull out, since this is over 2, I can rewrite this just to make the algebra a little easier. This is 1/2 times v naught plus vf times t. So all I did was pull out that 2, but it's 1/2. And now I'm going to substitute, I guess I should say, I'm going to put it in there. So we get that the displacement is 1/2 of the initial velocity plus all of this stuff, v naught plus at, all of that times t. So I just substituted vf for here. So now we get the displacement is 1/2 v naught plus v naught is 2 v naught plus at times t. So the displacement is multiplying across, half of 2 is 1, so we get v naught plus 1/2 at and everything times t. And then I distribute the t inside. I get the displacement is v naught t plus 1/2 of the acceleration times t squared. So we're almost to this one. So that's equation number 1. I just got to move that x naught. So this is displacement. But if I just want to know the final position But that's not hard because the change in position is the final position minus the initial position equals all of this. So all I'm going to do is just add that x naught to the other side. And we get x is equal to x naught plus v naught t plus 1/2 a t squared. And that's equation number 1. The last one we can kind of skip, and we're going to use, there's a couple different ways to get there. A complicated one is to solve for t over here and then plug it into this thing, but the algebra gets a little messy. And so instead what I'm going to do is I'm going to use this equation right here. So I'm using this one. So the displacement is equal to the average velocity, which is v naught plus vf over 2 times t. And then using the acceleration, so this one right here, so I'm using this. So vf minus v naught equals at. Because what I want to do for this third one, we have to eliminate time. So we just need 2 equations. And you could really pick any 2, just not in the same. Like I can't use this equation and that equation because they're the same equation. They've just been rearranged. So we got to use, they have to come from different places. So I use this one and this one. And then what I'm going to do, I'm going to solve for t over here, and then I'm going to plug it into this one, and then we'll solve that one. So solving for t here, I would just divide by a on both sides. So I get time is equal to vf minus v naught over a. Now we'll take that and plug it in there. So we get the displacement is v naught plus vf over 2 times t. And t is going to be vf minus v naught over a. So we can see that this is just a product of 2 fractions, 2 ratios. And so we can just multiply straight across. On the top, these are binomials. So I got to use FOIL or whatever you want to call it. It's a distributive property. But I would get v naught times vf. And then I do the outside, so that's v naught times negative v naught is negative v naught squared. We multiply the inside, that's vf times vf, so it's vf squared. And we multiply the last term, so minus v naught vf, sorry. And then we just multiply the bottom, so it's 2a. And that's all equal to the displacement. Okay, looking at the top, I have a positive v naught f and a negative, so these cancel out. So what I can do is multiply this to the other side. So I get 2a times delta x is equal to negative v naught squared plus vf squared. Now if I just move this over, I get v naught squared plus 2a delta x equals vf squared, and that's equation 3. It just has the vf on the other side. So those are the derivations. We've done all 3. This was equation 3. Oh, this part I know looks different, but that's just delta x. It's the same. So I know it went all over the place, and I went really fast. You don't have to know the derivations. Some people always ask. The key to know is that it always comes from definitions. So we define some stuff, and then we can get equations out of it, the relationships. These are called like first principles. First principles or definitions, stuff that we always start with. We end up where we are. Anyway, that was just for your pleasure.